front here and rear here, 5, 6. Okay. Now it is also possible, front, because it's a circular queue. When after 4, rear goes to 0, then again it increments to 1, 2, like that. So in this situation, can I perform NQ? NQ is allowed because I can add rear is here. Okay. But DQ is not possible because front reaches to maximum. But I have to make it possible because it's a circular queue. So whenever I'll see if F is at max, F goes to max, then element has to be deleted, then F becomes 0. Okay. So I have to make this DQ possible. Yes, deleting is allowed because after 5, 6 has been inserted. But display is a bit tricky in this case. How do you display elements? In these cases, I cannot display here. Here I can display from front to rear. And here how can I display? I can display it from front to rear. Here also I can display it from front. Yeah, here in these two cases the problem is how do, this is also front to less than rear. Okay, it's possible. But whereas here it's a bit tricky. If I want to display elements, then I have to write, I have to check that whether any one of these cases, whether the case for displaying is this or that. If it is that, then easily I can write from I runs from F to R less than R, then I will print all the elements of Q. But whereas in this case I have to write two loops. One loop is F runs from I runs from front to less than max. Okay. Then I runs from 0 to less than rear. So with these two loops I can write. It's not nested loop. It's two different loops. Can be used for displaying these elements. Okay. Now this thought will incorporate in our program and see its works. Okay. So now we'll just declare a queue, okay, int queue of size. Will define it to be hash define max size to be 5. Okay. Max. Then we have attributes front, rear. Okay, let's write the skeleton code first. Here I'll give choice and will allow the user to give his choice for enqueuing or displaying. There are actually 3 functions which can be invoked. If the choice is greater than this 3, then I have to terminate this loop. Then we'll ask enter your choice. First is NQ, okay, second is DQ, third is display, and fourth is exit. Then we'll take that in choice and see whether it works. At the same time, depending upon the choice entered by the user, we try to jump to a specific function. If it is 1, then we'll jump to NQ, ENQUEUE, come out of this switch. If case is 2, then we jump to DQ and come out of this case, and if case is 3, then we'll display the element. Case 4, of course, it gets exited. So let's provide body for NQ, ENQ, UE, UE. Then we'll have DQ, then we'll have display. I'll provide prototypes for all these functions. NQ, ENQU, DQ. It depends on your implementation whether DQ returns some element or not. It's not mandatory that it has to be wide. It depends on context. So here just for simulation purpose, how to write coding, we are only concerned about see, as far as algorithms are concerned, there are two things. One is analyzing the algorithm, and another is how to bring the logic. Okay. So we are working at first level, how to bring out the logic, then we'll do analysis on it. So it has one error, declaration syntax error in function main. Yeah. So this functions body cannot be nested in another function. Yeah. So we'll save with cq.c, circular q, right? So we'll check whether it's working. Yeah, sure, it's working. Now assume that I want to first implement NQ. Now for adding an element, I have to check that to make all these things simplify. See, this is the difference between implementation of queues with the help of linked list and implementation of queues with the help of arrays. In arrays, we can just give a variable called count, which keep tracks of how many elements have been inserted, and this count will decide whether the queue is full or not. So by this we may skip most of the logic for which we have to look for while looking whether queue is empty or not, in which case does it follows. Okay. So it simplifies our coding if we introduce a variable called count, which always keep tracks of how many elements are there in the queue, right? So what we'll do is I'll declare one variable count. So in we know that in all global variables are initialized to 0, but to be explicit, I am just initializing front and rear to be 0. Of course, count is also 0 initially. We have not inserted any element. Now, so while inserting any element into a queue, while enqueuing, while adding an element to a queue, I have to check whether the queue is full or not. So queue is full if the value of count reaches to its maximum element, okay, which is 5, then it means that queue is full. We cannot add. If queue is not full, then NQ is possible. Now again here, if queue is not full, then there can be many situations. It can be a case A, it cannot be case B, but it can be case C of 1, C2, C3, so any one of them. So what I have to do is I have to find out in which case we are in. So for that, what do we do is we'll use the attribute called rear. We know that whenever an element is added, rear moves or points to the next empty element in the cell. So we'll do what is if rear is equal to max, Okay, how do I find out? I want to add an element. Can I use count here? Yeah, if count is not equal to max, it means that count is less than max. If count is less than max, then NQ is allowed. It means if the if condition here in NQ, if this condition is not true, it means that we are sure that it is not case B. Okay. Either we are in case A or we are in case C. Okay. If we are in case A, no problem, we can just allow element to be added. But how do you distinguish case A from case C, and from case C, within this case C, how do you differentiate case 1 and 2, 3? For this, what do we do is, okay, we will check if rear is equal to max. It means rear is max, which is case C2. Rear is max, but count is not equivalent to maximum elements. It actually signifies case C2. Okay, case C2. Yeah. So in this case, what I have to do is, now tell me, in this case C2, is NQ is allowed? Yes, NQ is allowed, provided R should point to 0. Okay, please look to case C2. Okay. So we'll do like this. Rear, whenever it exceeds max, it will be reinitialized. It's something like mod operation here. It's something working like rear mod 5. Okay. So yeah,